Hello, welcome to 10 Minute Tute. Here's the question we're going to be answering today. It's what are the two types of waves and how can we measure them? We're going to answer this question by looking at these two learning outcomes, and they are to describe the difference between longitudinal and transverse waves, and we're going to define amplitude, wavelength and frequency, and to see how we can draw these on an example of a wave. So what can we use waves for? Well, we can use waves to transfer information and to transfer energy. Have a look at this water wave. Okay, a water wave transfers energy. We can see the energy moving along the water wave. But the particles are just moving up and down. The matter, what the water is made up of, isn't being transferred. So here's our first key point. Waves don't transfer matter, they transfer energy and they can transfer information. We have mechanical waves, which is what water is an example of, and these are waves which need a medium, which is a substance for the wave to move through. An example of this could be sound waves, a medium would be air, water waves, a medium would be water, or waves in a spring. We also have electromagnetic waves. These waves can all travel through a vacuum, a place where there are no particles. There is no medium for the wave to travel through in a vacuum. Some examples include light, radio waves and microwaves. Have a look at this question for me. Which of the following do waves not transfer? Do you think it's A, matter, B, energy, C, information, or D, data? If you said A, congratulations, well done. You've got it right. Waves cannot transfer matter, but they can transfer energy, information, and data. There are two types of waves you need to know about for your GCSE exam, and our first one is a transverse wave. A transverse wave looks like this. We have the wave motion going in one direction, and the particle motion going in a direction at right angles to our wave motion. We say that in transverse waves, the oscillations, which is another word for vibrations, are at right angles to the direction of travel and energy transfer. What does that mean? Well, let's have a look. The particle motion is going across to the wave motion. And that word across is hidden in our word transverse. Trans means across. If you take a transatlantic flight to America, you're going across the Atlantic. If somebody has a transplant, an organ's being moved across from one body to another. So transverse wave tells us really in the name. It's going across to our wave motion. And here's another little tip for you. In the middle of our transverse wave is an S. And there's a little clue for you. So put an S on its side, it makes a transverse wave. A little tip to remember that one. There's a special word we use in physics for this motion of particles and wave, and this word is perpendicular, which means at right angles. And if you can use this in your exam, you'll definitely be making sure you're getting full marks off the examiner. The second type of wave you need to know about is a longitudinal wave. In a longitudinal wave, the oscillations or vibrations are along the same direction as the direction of energy transfer. So we haven't got one going across this time, they're both going in the same direction. And we use the word parallel when we come to describe the vibrations in a longitudinal wave. Also in a longitudinal wave we have areas of compression where the vibrations are close together, as you can see labelled here. And we also have areas of rarefactions where the vibrations are spaced out. So have a go at this one for me. Can you name a type of transverse wave? Some examples could include light, radio waves, X-rays, microwaves, and in fact any electromagnetic wave is a transverse wave. How about longitudinal? Can you give me an example of a longitudinal wave? Some examples include sound waves, pressure waves, and waves being pushed down a spring. Right in. Let's see if you can remember those key words you mentioned earlier. Transverse waves vibrate what to the direction of energy transfer of the waves? Here's a clue. We're looking for a word that means at right angles. Perpendicular. So transverse waves vibrate perpendicular to the direction of energy transfer of the waves. That leaves a next one then. Longitudinal waves vibrate parallel to the direction of energy transfer of the waves. And if you have this question in your exam, these are the words you need to be using to describe these types of waves. Okay, well done. We've reached the end of our first learning outcome. We've described the differences between longitudinal and transverse waves. How confident do you feel now? If it's 4 or 5, if you're happy apples, then great, let's move on. If you're not too sure, go back and watch this part again. Time to look at our next learning outcome. We're going to look at amplitude, wavelength, and frequency. So here we have a transverse wave. And when measuring a wavelength, it's important to remember this key sentence. The wavelength of any wave is the distance between two matching points on neighbouring waves. So if I start right at the beginning of my wave and draw my pen along, I can't stop until I get to the exact same point on the next wave, which would be by here. I finish where I started. Here are some examples. I start at the top, take my pen, go down the wave and back up to the top, and I'm back where I started. That would be one wavelength. So in your exam, if you were asked to draw a wavelength in a wave, remember that's what you'd do. The wavelength is the same whichever two matching points are used to measure this distance. So all these wavelengths would be equal. The symbol we use to represent wavelength is the Greek letter L, which is lambda. You might see this in some wave speed equations. Okay, amplitude is our next one. And the amplitude of any wave is the maximum distance a point moves from its rest position. And when we're looking at a picture of a wave like this, the rest position is that middle line going across here. Here's some examples of an amplitude. Okay, we start at the rest position and go to the top, which is a peak, or we can start at the rest position and go to the bottom, which is a trough. Some people in their exams draw a line like this, showing amplitude, right from the top to the bottom. This is wrong. If you do this, you won't gain any marks in your exam. So the amplitude of a transverse wave is the height of a peak or trough from the wave's rest position. The larger the amplitude, the greater the energy of the wave. Think about a water wave. If the water wave had a greater amplitude, we can see it's a bigger wave. It's carrying more energy. The smaller waves you might see on the shore, don't carry much energy and they lap upon the sand. Our next keyword is frequency. And the frequency is the number of waves that pass a point in 1 second. Let's look at this top wave. Imagine these are the waves passing in 1 second. Let me count them. There's 1 wave, 2, 3, and 4. So on that top wave, 4 waves are passed in 1 second. Which wave do you think on the left has the highest frequency? Which one has the most number of waves passing in 1 second? Very good if you said the bottom one, because you are right. The bottom one has more waves passing in 1 second. Now, frequency has its own special unit, and that unit is hertz. So we said our top wave here had 4 waves passing in 1 second, so we would say it has a frequency of 4 hertz. Now, in your exam, again, if you're writing this unit, make sure you put a capital H for hertz. It's named after a famous scientist, otherwise you may not get the marks. A frequency of 10 hertz means 10 waves pass in 1 second. A frequency of 50 hertz means 50 waves pass in 1 second. What do you think a frequency of 300 hertz means? It means 300 waves are passed in 1 second. And there we have it, our second learning outcome done. We've looked at amplitude, wavelength, and frequency. And we've measured them on our wave. So thank you for watching our 10-minute Tute session. We've now answered our objective question, and hopefully now you've got more skills, tools and knowledge entering your exam. Good luck and well done.